In this video, I'm going to show you how to query for multiple documents using using Go, and this is for a Mongo DB database. So we're going to use the Go supported Mongo driver, so the one that MongoDB actually puts out. We'll be querying the database and getting multiple documents. So if you're just here to copy and paste, on my screen here, you can see the code that you need. I've included a link in the description below. You can just head over to my website to this exact lesson, copy, paste, and use as is. In this video, we'll take some boilerplate code and we will actually execute. We will it has authentication and it has a few endpoints, and we'll execute it. We'll see how it works. I'm making a few assumptions here. I'm assuming that you have Go installed on your computer. I'm assuming you have Mongo installed on your computer and it's running. And I'm gonna use Mongo Compass to visualize the data. I'm gonna use this repository here. It's called Go Boilerplate. You can start if you use it or fork it if you'd like. This will be my starting point. This is just my way of getting you up and started with a fully running API, and allows everyone to start at the same point. So the first thing you're gonna do here is we're gonna clone this to our local repository, to our local machine. Sorry. I'm going to do the same thing, and I'm going to do it on my desktop. If you don't actually want to clone the repository, you can just go to download zip. That's your other option. I've now downloaded the Go boilerplate code. I've unzipped it and I've placed it into a folder called Query Multiple on my desktop here. Next, we're going to be opening this up in an editor. You can use any editor you like. I'm going to use Golang. It's just a personal preference. The only other thing you're going to need for this project is a REST client like Postman. So I'm going to open project, desktop, query multiple. I'm just going to open up this project here. Okay, so let me start by just kind of explaining this boilerplate code. And I'm going to do so just because we're going to have to take a few initial steps. So I follow pretty much a pretty standard pattern. Handlers, which handle our HTTP requests, services, which handle the business logic, repositories, which is any sort of your data access layer, and then models is like any sort of struct that you have. And so each section has something that ties. So in this case, there's the user, which is anything like authentication related, and then there's the cars, which is a basic CRUD app. And what we're gonna be doing, if you look at your main.go here, open it up. We have a validate auth here, so there's some authentication here. So we have these endpoints here. So user/signup, user/signin, and logout. We're gonna need to create a session token to be able to access these values here. And if you open up models and then cars, you can see the car object, and that's what we're really gonna be working with this CRUD example. So we're gonna add a number of them into the database, and then we're gonna start querying for multiple of these different cars, and we're going to add some pagination, and you're going to see how that all works. So the first thing we have to do just to get this going is, one of the things with this boilerplate code is that there's no encryption set up. So I chose not to include bEncrypt, but I did include a warning around it. So all you have to do is open up services and then user service. So one of the methods that get called is valid password, and if you click it and open up that method, you can see that since there's no encryption and everything's in plain text, I leave it automatically say that all passwords are invalid. What we're going to do is just going to remove that and set it to true. That means do not use this in production. You're storing plain text passwords. It's not secure, but just for demo purposes, it's fine. So now that we've changed that, I'm going to close that page. We should be able to run our app, and we should be able to get that authentication token. So I'm going to head back to my desktop, my main desktop here, and I'm going to open up my Postman. Postman is a basic, REST client. You could do curl calls. That's another option. We're just going to make these one post request to the sign up endpoint with a email and password, It'll give us back an auth token, and then that auth token allows us to authenticate against the endpoints, the car endpoints. So I actually keep these stored on my local. Pretty simple. So it's a post request. It goes to HTTP localhost 8080/user/signup. The headers is just content type application JSON. And then if I click the body tab, it's a little slow. I select raw, and then it's an email, and it's a password. Demo1 is my password. And then the response will be that auth token. We need to start our application, so we're ready to send this sign up request, but we first need to start up our application. So I'm just gonna head over to my area that I'm working in. So query multiple is what I'm calling the project. Make this a little bigger. And all I have to do is go run main.go, and that should start up the API. Perfect. I'm just gonna hit my send request here, and I get my auth token. Okay, so now that we have that, I'm gonna actually take a step back. I'm gonna show you the insert method. It's fairly simple. We're gonna insert a bunch of data. Actually, I'm gonna do that one first because I have another video. I'll link to it in the description. It's about saving data in Mongo. So since that's not really relevant to this video, it's just this post cars. So again, a post request, localhost /cars/ and then what we're gonna do is, you can ignore version, you don't need that one. Content type, and then application JSON, and then authorization bearer, and then I'm gonna paste my auth token in there. Here's my first car, so I'm gonna hit send. It's gonna save the car. I'm gonna pull up my database in a second so you can see it. I'm gonna change the year on here. I'll save again. I'm gonna change it to be, I don't know. I'm gonna keep doing this actually though, because I want to show you the pagination. So 3. So what I'm doing here is just, I need to put a whole bunch of data in there so you can see we page through multiple pages worth of data. So I'm just incrementing the year by 1 so they're all semi-unique and you can see the different pieces of data. I'm going to open up Mongo Compass. You can see that the database information of, sorry, it just opened up and moved me back. You can see the database information. So again, I'm in this main.go file. Scroll up a little bit to this main function, and you can see my database name is DemoDB. It's gonna, and you can select it. Sorry about that again. I can select it, and you can see it connects to this localhost 2017 17. So let's go check out DemoDB. So this is Mongo Compass. I'm gonna connect essentially using no authentication or anything like that. I have my DemoDB. I have 15 cars in there. A couple Ferraris, and then a whole bunch of Jaguars, as you can see. So there's 15 pieces of data in here. I have 1 user in 1 session. It's exactly what I need. So let's take a look at this query multiple endpoint. So scrolling down here, I'm still in my main.go file. I have a get request with just / and that's the get all. And then I have a get request with the get by ID, and I pass the ID in. We're gonna be focusing on this first one, the get all. So if I look at my cars handler, get all, so I'm gonna navigate this way. So handlers and the cars handler. So we have this get all. So essentially I fetched the session out of the gin context, kind of irrelevant to this one. And then I take a number of query parameters here. So as I mentioned, we're going to support pagination with this. So someone's trying to pull all the cars that they own, and they have hundreds of thousands of them. I don't want them to pull hundreds of thousands of database elements. It'll put a lot of traffic on my database, so I want to paginate it. So essentially I set a limit to it. So let's say 250, or in this case on the screen it's 25, and then I page it. So I say, you start on page 1, and then if you want to see the next 25, you can increment the page by 1, and it'll show you the next set of 25, and so on. So in practice, very common, buttons on the bottom of the screen that would have like, next page, and it's very, very common. Or if you do like some sort of scrolling where as someone approaches the bottom of the page, like the actual window, it then increments the page and then sends out another request, is another very common approach to this. And then the next 3 query parameters are make, model, and year. These are additional attributes to the car. And what's happening here is we're going to use them as kind of filter parameters. So the next step here is a year, is these all come in as string values. So the year we actually want as an integer, the page we want as an integer, and the limit we want as an integer. Now, if someone gives me like a page of the word foobar, that should break. It'll throw a 400. It'll give them some nasty response here. What we actually want to do is just log an error there, and probably say, page is an invalid format. It must be a number. What you also want to do here is limit the values for limit and things like that. So you don't want someone to be able to set limit to be 250,000, because then you don't want to actually make 250,000, like pull 250,000 database objects. So next thing we do here is we build a query. So this is a struct. It's found under models and cars. So it has the page, the limit, the make, the model, and the year. The JSON tags aren't actually required since we're building it in Go. So we fill in all those information. So make, model might be empty strings, and the year might be a 0. And then the last one is page and integer get defaulted to be page 1, and the first 25 items, like 25 items is the list. Does the validation, and then we call the get all service where we pass in the session in this query. I'm just gonna, so we don't have to return to this handler. As you can see, if cars comes back as nil, we just like set it to be an empty array, and we return that as a JSON object. So let's check out this service. So it'd be under services and the car service. So here it is. Super simple. We just call like the cars repository, so that data access layer. We call the list method with an email and that query. If an error is thrown, we pass back the empty array of cars and the error message, and then we'll populate that up to the UI. So let's check out this list. Again, now I'm in repositories in the cars repository. So as I mentioned, email's taken because, let me just show you in Compass. As you can see, the user's email is the primary key, and it shows who the owner of the object is. So it's one of the attribute fields. Okay, so we have this list, and what we do here is, if you see query.filter, this is my way, and sorry, when I say my way, many people do it. It's a way to return back. So what we're returning is like essentially a map interfaces. So it's a BSON document, and it's this here. We're returning this, and we were building this filter object. And so we'll build this filter object. We'll set some options, which handle the pagination. We have to sort it so that we get the same results every single time, and then we make the query. And I'm going to circle back to all that. I just want to focus on this filter object. So this filter function is found under the cars, and just below the list car query. It gets attached to it, so you can just do like the query.filter. And in this case, we pass an email because email is not part of the query struct. So we're going to do an and filter, because if you think about it, we have, so ignoring page and limit, if you think about it, if the email is provided, so someone is authenticated, we want their email to be associated with the object. And then we don't know if the make, the model, and the year are all optional fields. So if make is set, we want to say, okay, and look for email and make. If make is not set, we just want to search for email. And the same thing is true about model, and the same thing is true about year. So we say, here's the list of and filters. So it must have email. if make doesn't equal empty string, we want to pull out all the exact matches of make. And this is some regex, and I've just added this in here. Sorry. Essentially, we want it to start. So this indicates like the regex for start with, and then finish off with the wildcard. So, or if it's a similar match. So, for example, I pass in the query parameter, and I'm looking for a Jaguar, and I put JA, and I own that. It's going to pull back a Jaguar because Jaguar starts with JA, but if it ends with that, it won't pull back. And so essentially we're going to build some or filters here because it doesn't need to be an exact match and similar to. It's either or work. So or, and then we add that onto our ands filters. Same exact thing with model, exact match or similar to, or starts with it pretty much. And then the last one here is year. If the year is not set to 0, so if it's not empty, there's no, you can't put in 19, right? Because you'll get everything back really. So you really want to be explicit with the year. So either they have the year correct or they don't. And again, you could put a range in there if you want. So greater or equal to, that's another option, but I chose not to. So for some reason, if the and filters are empty, return nothing. This will actually never happen because there must be an email, but I put in there just to handle that extra case. And then otherwise return, this is the Go notation, not the Go notation. This is the Mongo notation for the and filters. So it's like $and. Here, let me just quickly show you what I mean. It looks like this. It's going to be like this, and it's going to be an array of requirement fields. So in this case, if I didn't set a make or model, it would just be an empty. It would be the single item, and my query filter would just look like this. So this gets returned, and we get back up to here. Next, we want to set the options. The options here is this idea of limit and skip. So in this case, the limit is the maximum we want to return. So in this case, 25 is our default. Next is the skip. So we want to skip to a certain integer pass. So if we're on page 1, for example, so maybe 1 times 25, which is 25. And then we just want to subtract the limit. So we go back down to 0, because if we're on page 1, we want to start at the 0 element and then get the next 25 of them. If we're on page 2 times 25, 50, minus 25, it's back down. We jump to 25. This is just my way of handling, I don't want to start on page 0. I want to start on page 1. It makes more sense. I know we as programmers start at 0. However, I found that it's pretty standard to start on page 1. So that's just how I do it. If you could also just do subtract 1 on the page and then multiply by the limit, but that's another option. And then this last part is sorting it. Sorting is incredibly important because if I'm doing pagination, I need to know that my results are coming back in the same order every single time. So in this case, I sort by the created timestamp. So we make our filter. So we use the find method here. It's a fairly standard Mongo method. So our DB connection. So this is the Mongo client, and you can find more about that in the db.go file. So it's this instance of the Mongo client. Let me just jump back to my cars repository. Dot the collection, which is in this case cars. I provide the cars name. Dot find. I pass in the context, the filter, which is our BSON map there, and then essentially our options, which we've set up above there. And it returns a cursor and an error. So if it's an error, we just return an empty array of cars and their error, and that gets populated back up to the API layer. And then we, fairly standard, we iterate on the cursor. So as long as there's a next, we kind of do a loop. So we loop through, and for each cursor element, we decode it into a car object, and then we append cars. Now the one thing I haven't handled with this case, and I'm not happy that I haven't handled it, is if something goes wrong when decoding it. For example, I don't know if there's invalid fields or something like that. I don't actually have a way of handling it. It just simply doesn't get added and gets ignored. So if you're fetching 25 items and half of them don't have an invalid field, you might get 0 back. I actually don't handle this case. if you want, you return like, I don't know, some sort of additional error or optional error or something like that, like third attribute. I just chose to ignore them simply because querying multiple documents is kind of a low risk activity. So that's everything here. So let's just start by testing all this out. So for testing here, we know some information. So what we're going to do is just return all, and I'm going to just show you the pagination. What we're going to do, because we never actually restrict the limit, and I very much recommend, just going to jump back over my code base for a second here. In this services method, actually the one that I didn't really do much here, this get all, I would check that the query is a certain range of fields. So it looks something like this. I'm just going to add it right now. So limit, doesn't equal 25, and query limit doesn't equal 5. It's going to return an empty list of model cars because it doesn't matter. And then I'm going to just specify the error. And the reason for that one is, again, I don't want someone to be able to set their limit to be like 250,000 and then just like pull everything from my database. So I'm just going to import my errors here. Doesn't like punctuation at the end there. And I just set it to be 5. I did that just so because I only have 15 elements. I want to just demo it. So let's do this. So I have my auth token still. I have data in the database. We've done all of that. So I'm going to head back to my Postman here. What does this API call look like? So here it is. It is a GET request, HTTP localhost 8080/cars. I need to restart my API since I just made some changes to it. So I'll do that. So I just did Control C to cancel it, to stop the API, and then just did run main.go. Start back up. Heading back over to my REST client, Postman in this case. Let's head to our headers here. So I'm just gonna head back to this one. I'm gonna copy this same header. So this is my create car header request. I'm gonna update my header here. So get request localhost 8080/cars/ headers are content type and with application JSON, and then we have authorization and then bearer and then my auth token. There is no body here because it's a get request. We're gonna start by just hitting send. What this is gonna do, it's gonna default to page 1, and it's gonna have limit of 25. Hit send here. So let's just take a look at this, at my response. It worked, which is a great sign. And as you can see, it's sorted by created and descending. So the year 2032 is my most recent element. So that you can kind of say that's working. 2, 3, 4. I'm pretty sure it just returned them all. Yeah, all the way up to Ferrari 1994. So they retrieve them all because I only have 15 elements and the limit is 25. So let's try using that limit of 5. So I'm just going to do question mark and then limit and just say 5. Let's do a send again. So 2032, 2031, 2030, 2029, and then 2028. And it only returns me back up to 2028. So let's say I need the next set. So now we can start to specify the page. So page 1 in this case, and that should actually return the same results. So 2028. I want the next set. So let's say I'm either scrolling or tabbing through on a website. I send the same request out. Now it returns 2027 all the way down to 2023. And then this should actually be the last page of them. So page 3, which would give me back 2022 all the way down to Ferrari 1994. So again, 5 elements. I can now page 4, for example. It's going to return nothing. So we can see the pagination working. So let's try out some of the filter attributes. So I'm actually going to remove. I'm going to leave the limit and I'm going to remove the page, and then I'm just going to say like make is Jaguar, or I'm just going to say Jag, and it should return back the first 5 Jags. So make is jag, and it does. It returns 2032 back. Let's try putting in. I'm gonna put the whole word Ferrari in. It returns both Ferraris. Let's be a little more specific. Since they're the same model, let's just ignore that one for now. Let's put a year in. So let's say 1994. It returns only the one Ferrari. So as you can see, all of our queries are working here, and that's pretty much it. I have a video on querying a single document. It's in here. It's right here. Same with update, get, delete. They're all coming out. Please subscribe. Thanks for watching.